So I want to show you, just in case you like this method better, I want to show you another way to kind of put this together. I'm obviously not saying you have to do it this way. Personally, I don't like doing it this way. But if you know the form of the answer, it's unfortunate that it's going to be it's too bad this guy's F. Too bad. Then you can identify the top. You can identify the bottom. You can do their derivatives. And then you just plug all these pieces back in, which is not mathematically any different than the way I was doing it before, but organizing it like this sometimes helps people see how things go together. So this would become f prime is 1, g of x is x squared plus 2, minus f is x plus 3, g prime is 2x, all over g of x squared, right? That's perfectly fine. Nothing wrong with that. It's basically the same thing I did, just kind of reorganized. So then you get x squared minus 2x squared is negative x squared, 2, and then minus 6x. And that is not going to reduce. Coolness, I like it. Let's try to do this guy straight up. Let's see. G prime will be the derivative of the top. There's the bottom. The bottom gets his turn. All over the bottom squared. The top first. Keeps you straight. What's this guy's derivative? The 1 goes away. Negative comes down, makes it positive. X to the negative 2. I like it. Yeah. What's this derivative become? It becomes 2 goes away.
Negative 2x negative 5.
I like it. But I really want you guys, I don't know. All I cared about was what that guy's derivative was. He had just write down. He had just write down. What's his derivative? Bam. That's there. I mean, so you just focus on one piece at a time. Everything else stays the same. And then I just got to clean up. So it'll be plus 2x to the negative 3 minus 2x to the negative 4 and then let's see, I just have one set of like terms on the top. Yummy. I'm really curious, and I know I sort of shut you down a little bit. Once we get past the sections that deal with specific rules, like product quotient rule and chain rule, then you must start simplifying the function first. Did anybody think about how to simplify this function first? What's disgusting about this function particularly? The negative powers. I love it. Which really means there are x's on the bottom within a fraction. So it's fractception, right? Fractions within fractions. So I can multiply top and bottom by x squared. And then there's no fractions within fractions. And mathematically, the answer I get will be equivalent to this one, just not as gross. So I could have multiplied top and bottom of this by x squared. So I get x squared minus x over 2x squared plus 1. And if I do this guy with quotient rule, I will get something that doesn't look like this, but it's mathematically equivalent to this. Yes?
But right now you don't want us to do that, right?
No, well, I mean, this wouldn't be that big of a deal. Did I change it from a quotient rule to something else? No. So this kind of simplification, dear God, yes.
Okay.
Right? But foiling, when they want you to do a product rule, no. You've got to get used to the rule. That's why it's frustrating when you learn a new rule. And you're like, there's a simpler way to know. You got to get used to the rule. Right? And then when we get a little bit further down, you do whatever the shit you can. So if I gave you this, so where you got this piece? This is older, yeah. If I just said, find the derivative of this, I would hope to God you guys simplified it first, right? If I said find the derivative using quotient rule and then by simplifying first, which is what they're going to say in the homework on a few problems, then obviously you have to use quotient rule first, right? They just want to show you get the same answer either way. But my God, if I just said find the derivative, dear God, factor, kill, easy. Okay, maybe. Let's see, do I still have... Ooh, that's kind of gross one. Shoot. What was the... somebody help me out. What was the first derivative we got, that first problem? I wanted to do more with that. What was the first guy's answer? Somebody got that? For the first problem we did.
Negative x squared plus 2 minus 6x over x squared plus 2 squared.
This came from the function x plus 3 over x squared plus 2. So what if I said find equation of the tangent? By the way, I think I've done this a few times. Everybody cool with it's a quick way to write equation. Equation of the tangent line to bam at -3, 0. So why was I really nice? So I gave you a full point, right? I could have just said add x equal -3, and then you have to plug it in. Ooh. But what are you missing then?
B.
Well, I don't care about p. Right? We got y minus y1, mx minus x1. What's the fundamental? I got a point. Check. What else do I need? Slope. And how do I find the slope? I got a function that tells me the slope anywhere. So I think, go ahead. What do? Yeah, plug -3 in. What's this function's purpose? It tells you the slope of this dude anywhere. So if I plug in -3, what do you guys get? Over 49, I think it is. That's yummy. Right, you get -9 plus 2 is -7, plus 18 is 11, over 9 plus 2 is even worse than I thought. It's better than I thought. 9 plus 2 is 11 squared, so I get 111. It's all right? Oh, you guys are like, sure, man. You're the math boy. Sounds good. And now you just plug and chug, right? And remember, I told you, this question is going to come every single section just about. You're going to be like, good question again, because we're going to keep learning a new rule. We're going to learn derivatives of trig functions very soon. So then they're going to ask you find the equation of the tangent line, so cosecant of 4x minus 2 at the point blah, 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 right? What do? Same shit every time. Same shit every time. I like it. They're trying to remind you that when you take a derivative, what you get is the slope of the function you started with everywhere. That's crazy. That's really hard to remember, but that's true. So let's see, what do we get? We get y minus 0 equals 1/11 times x minus 3. So I get y equals 1/11 x minus 3/11. So that line touches this function perfectly at this point. Okay. Function can talk to HR if it needs to, but I don't know. All right. So the last thing on tap for today is kind of a big one. We're going to do the derivatives of the trig functions, the basic 6 trig functions. We will eventually do the inverse trig. Yay! I want you to do something for me. If we're trying to investigate the derivative of sine, can you set up what I need set up to look at that? I'm trying to figure out what f prime is. I know some of you guys know what it is. Whoop-de-doo. That means shit. It's easy to memorize. What's this? No, I don't care. Can you prove it? So what would I need to set up to find out what f prime is? How would I do that? If I don't know what it is, I have to go back to what? Definition of derivative, the limit definition.
Yeah.
Try to put the stuff in there. See if you can get anywhere. Go ahead and set that up. So the function sine of x, there's what I need to look at to figure out the derivative. You might need some trig identity. Is there anything you can do with this? There are trig identity related to the part of this that has multiple things going on. Yes. It's the one
Sin x cosine h plus
Yeah.
cosine.
you have to know this one. Sine is the nice guy, right? Sine says, we'll take a turn cosine. So I'll do x and you do h. It's a plus, so I keep it a plus. Now I'll do h and you do x cosine. I like it. And now this is kind of freakadelic, right? So let me break it down a little bit for you. Where'd it go? Oh, yeah. So just took a sine x out of here, cosine h minus 1, and then here's the other piece. So if I write it like this, I can identify the ratios involving h. Now why, for example, let's focus on this guy first, because I need this guy's result to even look at this guy. This guy right here. What form is that in if I try to plug 0 in? What sign is 0? 0. And as h goes to 0, h goes to 0. So it's 0 over 0, right? Which is obviously a problem. But that means I could do something. I could actually figure it out. Maybe it's some finite number instead of some infinity, right? So here's the funky thing about this limit. How can I investigate this limit? We don't know what it is, so what can I do to investigate it?
As close as possible.
Yeah. So whoever's got their calculator handy, what are you going to try to put in there? Let's put sine of 0.01 over 0.01, and then do sine of 0.001 over 0.001.
The second approach is 1.
Yeah, I like it. And this does. What's really neat is that if you graph sine and you are very careful about what it's doing right here, this slope through 0 is actually 1. So it's approaching 0 at the same rate as this is. Because this guy's slope is 1, right? It's 1h. So there is something that some of you guys can't wait for. It's called L'Hopital's rule. I can't remember if it's come up before or not, but ain't no way in hell you can use that yet. We're nowhere near that shit. So don't get too excited. But this limit does come out to be 1. So in physics, very often what you'll have is this pendulum or something that's periodic in nature, and you say, if I pull it just a little bit, h amount, then the sine of the angle is approximately equal to the angle. The smaller the input for sine, the closer sine is to that number. So try it out. Put what's sine of 0.000349? Hope you guys are in the right mode. You got to be able to interpret your calculator. What do you guys get? You're afraid to say. I don't know. You guys know how to interpret what you get? You should get 3.489999 e negative 4. What the shit's that mean? So if you're playing along with me, you should get 9 blah blah e negative 4. What the shit is that? The answer is obviously not 3 point something. I love it when people just write this part down. I'm like, sine goes to 3. All right, that's a good job. It is exactly scientific notation. It's times 10 to the negative 4. So you just move the decimal once, so then 3 zeros. So it's 0.000348. Now, so what do we put in? We put that in. We basically got that out. And the smaller your input, the closer the result is to it. So what is this limit going to be if these values become these values? The closer you get to 0, it's freaking 1. That's exciting. And then something very similar, just to kind of cut to the chase here, something very similar happens with this. What happens to cosine as you get closer to 0? Well, what's cosine of 0? 1. So then the top is getting closer to 0 at the same rate the bottom is. So that the ratio becomes 1 again, the same reasoning. I love it. That's not, they have a geometric proof and all this kind of shit. You can read through it if you want to. But what's important here then is, let's see what happens here. Oh shit, I just took that away. All right. Sorry, I just need this. So again, limit of h goes to 0. Let me write this down again. So this piece is going to 1. This piece is going to 1. Oh, did I do that right? No. This piece is not going to 1. That's my. This is going to 1, so what's this whole thing going to? 0. So then I get what? I get a limit. I don't need the limit anymore. I just apply the limit. So this piece, since cosh is going to 1, cosh h minus 1 is going to 0. This piece is what we just looked at. That's going to 1. So sine x times 0 is gone. 1 times cosine x, cosine x. So this piece, I was focused so much on what this guy was doing. He's going to 1. Therefore, this whole thing is going to 0. And look, we kind of already knew this. Here's sine. And if I started graphing this guy's slope,